Okay, students. Now we will solve another problem on Euclid division lemma. Here, the square of any positive integer is of the form 3p or 3p plus 1. Now, by using division algorithm, here b value becomes 3. B value becomes 3. If we put b value here r value lies between 0 and 3. R maybe takes 0. Means here b value, r value becomes 0, 1, 2. Here put r values here. We will get a is equal to 3q plus 0, 3q plus 1, 3q plus 2. Just found r values, substituted r values in division lemma. We got positive integers as 3q, 3q plus 1, 3q plus 2. Here we have to prove square of these positive integers. Square of positive integers. These are the positive integers. Now we have to find out squares of positive integers. Now I am proving as cases. Case 1. Let a positive integer as 3q. Now squaring on both sides. Squaring on both sides. We will get a square 3q square. Here a square becomes 9q square. Here a square becomes, we may write this as 3 into 3q square. 3 into 3q square, we will get 9q square. Here q is an integer. If we write an integer instead of q, we will get another integer. Let that integer is 3p, since 3q square considered as p. This is the case 1. Now take case 2. In case 2, consider positive integer as 3q plus 1. Positive integer as 3q plus 1. Here also squaring on both sides. Why? We have to prove square of any integer. These are the integers. That's why we are squaring. Here square becomes 3q plus 1 whole square. 3q plus 1 whole square means which is in the form of a plus b whole square. First a square, then b square plus 2 into a into b, which becomes 9q square plus 1 plus 2 3s are 6, 6 1s are 6, 6q. Now we may write 9q square plus 6q plus 1. We may write 3 common from these two terms, which becomes 3 3s are 9q square plus 3 2s are 6q plus 1. Here q is an integer. If we take q as an integer, this number also becomes an integer. Consider this integer as p. Therefore, square of integer now we got as 3p plus 1. Here in previous case, square of an integer is of the form 3p. Now consider third case, case 3. Now square of positive integer, square of another positive integer is 3q plus 2. A is equal to 3q plus 2. Here also squaring on both sides. We will get a square is equals to 3q plus 2 whole square. Here also apply a plus b whole square. A square plus b square plus 2 into a into b. Here which becomes 9q square, 4, 2 3s are 6, 6 2s are 12q. Now we may write 9q square plus 12q plus 3 plus 1. Write this 4 as 3 plus 1. Now from these 3 terms we may write 3 as common. 3 3s are 9 q square, 3 4s are 12 q, 3 1s are 3 plus 1. Now here q is an integer. If we write any integer instead of this q, we will get another integer here. Suppose this integer as p, we will get 3p plus 1. Therefore finally we got a square is equal to 3p plus 1. Always here in this case, square of any positive integer. Here a is the positive integer. Square of positive integer is in the form of 3p here. In this case, square of positive integer is in the form of 3p plus 1. Here in this case, in third case, square of positive integer is of the form 3p plus 1. Finally, the square of any positive integer is of the form 3p or 3p plus 1.